Hi, and thanks for coming to the Spokane.net Users Group first online live event. So happy you're here. I saw quite a few new names on our list, so I'm excited to introduce you to our little group here in Spokane. Hopefully you're here for the right thing. We are presenting Essential C# 9 with Mark Michaelis and Kevin Bost. And let's see, for those that are new, the Spokane.net User Group is sponsored by Intellitect. It is a local software development firm here in Spokane, and they are always hiring senior developers. So if you're interested or looking to change jobs or move to Spokane, you can go to intellitect.com/jobs. And our meetings are usually the second Tuesday of every month. That has not happened lately, but we're hoping to kick that back up now that we know how to, now that we're doing them online. Let's see, I believe all of you are registered on that group. If you're interested in more meetups, we are also connected with Spokane DevOps group, and they have a meeting this Thursday that you're welcome to join. Just search Spokane DevOps Meetup and you will find that. Our next meetup will be the second Tuesday of December, and we are focusing on .NET 5 based on today's .NET conference. Also, just some ground rules with the chat box. Please ask any questions you like, and I'll be fielding those to Mark and Kevin for you. They love questions, so ask as many as will help you out. Again, as I mentioned in the chat, if your company is hiring, please let other devs know and include the direct link to their site. If you'd like to suggest future topics for our events, or let us know that you'd like to speak at a future event, please send that over to me as well so I can write that down and we can help you out there. Lastly, I'm going to introduce Grant Erickson. He's the CTO of Intellitect, and he will be talking about our speakers for today.
Hey, thanks, Erin. I will be introducing, I have the distinguished privilege of introducing Kevin and Mark tonight. Let's start with Kevin. It's Kevin Ferdinand Bost, who is a Microsoft MVP. And whenever I introduce Kevin, I always talk about, I have this friend, this coworker who does this amazing stuff with like IL weaving and things I've never even dreamed of doing in C#. And when I think about Kevin, he has a knowledge of C# that is so deep that goes beyond just knowing the syntax, but knowing like how it all works behind the scenes. And so I think it'll really be a treat to hear from him and some of the insights that he has on C#. And secondly, I'd like to introduce Microsoft Regional MVP, or Microsoft Regional Director and MVP, Mark Aloysius Michaelis. And he obviously, as you can see in all the slides and stuff, he wrote the book on C#. And I just want to let you guys know that working for a company where he is actually a pretty painful thing because he thinks he actually needs to do the things that he wrote in his book. I mean, it's not good enough to just, hey, write down, you should go do these things. But he actually expects us to do them too. And I can't tell you how many hours we've spent in meetings haggling over things like, what should we really do about nullability? Because at the end of the day, we all have to do it. And so the things that get written in the book and the things that we do at Intellitect, he says, hey, these need to be the same. We need to be doing whatever we're going to write. And I think I really appreciate that level of just authenticity and willingness to go the extra mile when it comes to figuring out not just what we think is the right thing, but what are the things that we are going to actually do and implement. So without further ado, Kevin and Mark.
Thanks, Grant. Erin, next time we do this, we need to get somebody else to introduce us, please.
No way.
I don't think that's possible.
Okay, so tonight we're going to be talking about C# 9. And for those of you who don't know, it actually came out today. And so we, of course, have updated all our bits and made sure the most recent releases are out there. And so we're going to go ahead and talk about the various features that are included with C# 9. We're going to cover sort of 99% of them. There's a couple of esoteric ones that we're going to mention, but we won't talk about much. as they're pretty rarely used. So, Kevin, you there?
I am. Give me 1 second. I just realized I am an amateur and I clicked the wrong button. So if you can pause for one moment while
Hey.
my world ends real quick.
We have Kevin's photograph. How about your camera?
Yeah, I was going for that.
Kevin has so many buttons in front of him that are all hardware related. He doesn't do software anymore. He's got a whole production setup. It's all done in hardware.
Yes. And anybody who follows my Twitter handle will also know that my production setup is held together by spare sprinkler parts. So
Yeah.
there's that.
As of what, the last 24 hours, correct?
No, I've been doing that for months.
Oh, okay.
It turns out sprinkler parts are rather durable.
Okay.
One thing I'll call out real quick. Normally people might use the word fingerprint. One of us, I won't mention his name, but it rhymes with Kevin, couldn't type fingerprint and kept typing fingerprint. So that's what we're going with tonight. So tonight's lesson will be all about fingerprints.
But it was intentional. It was definitely intentional.
Yes.
Okay.
So before you jump all over my case, no, I can't spell. Okay. Let's do something C# related.
So the first feature we're going to talk about is going to be records, which turns out we've actually seen now for 2 different releases, but they never made it to production. And so finally now in C# 9, we're going to get into talking about records. And it's basically a provides a sort of set of shortcuts for declaring properties and declaring some functionality about the behavior of your class. But it has some surprising characteristics that you'll notice as we get started here. So we're going to go ahead and declare a fingerprint because that's what we want to call our class. And Kevin, you're still there? Why don't we go ahead and declare that record? You'll notice that in this case we're putting a record within a class. The class is our test class, and then we're going to go ahead and define a nested class in that called a record. But obviously you can put that out further if you want to. That's not a problem to go ahead and do it at the root level, right, directly with your namespace. That's fine too.
Yeah, the one thing I'll point out for people is record is just a new fancy way of writing class. A record under the covers really is just a class with some fancy syntax. So what you can do with, or where you can place a class is the same place where you can put a record.
Except it's got some restrictions. So even though we've gone ahead and defined it as a record, you can't go ahead and have a class derived from a record or a record derived from a class. And so in spite of the fact that it's exactly like a class, as Kevin said, inside the IL, the actual constraints by the compiler prevent you from going ahead and having a hierarchy of records and classes. They have to all be records. You can go ahead and do things like implement interfaces. So you can have any record implement an interface. You can have records derived from each other, but you can't have records derived from classes. But there's some additional interesting syntax that you can do as well. So we've gone ahead and defined the fingerprint class here. And maybe we should put a test in there, Kevin, just to show that this is just a standard class. You can instantiate it.
The problem is you're gonna insist that I actually spell the other words correctly.
Because spelling pubic, I think that's better. So you've done better than I do. So we're going to go ahead and declare fingerprint, and you'll notice that there's something different about the way Kevin has done this. This has nothing to do with records. He happens to be using a record, or we happen to be using a record here, but there's nothing specific about records that enables this functionality. But rather than us going ahead and defining fingerprint on the left and instantiating specifically and explicitly a fingerprint, we can now go ahead and just use the new keyword to instantiate the data type. And by doing that, we only have to specify the type once, in this case on the left. And this replaces the need, in fact, except for when required, for you to use var. You can now go ahead and just type the data type once, put it on the left, and that will replace the need for you to define it on the right. As long as it can be identified by the compiler what the type is, then you can go ahead and put it on just the left and not on the right, even though you're using the new keyword. However, if you can't use var and then just set it equals to a new parentheses, because of course when you do that, it won't know what the data type is, and so you couldn't do that. And also, if you're trying to cast between a base class or a derived class, you'll need to specify specifically what the data type is you want to go ahead and assign or instantiate. So another shorthand that we should mention here is you can actually go ahead and specify the constructor parameters and the properties of the class that you're defining or the record that you're defining by specifying them right directly within the parentheses that appear right after the record declaration. So Kevin's going to go ahead and put in here that we're going to create a fingerprint and it's going to be created by property. And you'll notice by doing that, it turns out that we can now actually check the created by property inside our test. What's the value that's going to be assigned? So in this case, we've gone ahead and defined a constructor. Because there's a constructor, we must specify the values for the constructor. This is now the only constructor that exists, and the default constructor is no longer generated for you. And so we can pass in this case, just the created by value of Inigo, and that will go ahead and a constructor will be generated for us. So we can now go ahead and check the created by property on that object we just generated.
Yeah, so the signature that you see up here, so these are called positional members for those people who are interested. So the signature of the constructor that gets generated for this record looks like this. So I obviously have the ability to do Humperdinck in here as well, assuming I can type, because I do have that optional modified by as the second parameter to the generated constructor.
And then can you go ahead and check, shall I demonstrate that there's properties on there? So go ahead and do a...
Sure, you're going to actually make me give it a name.
Let's give it a name, yeah, let's give it a name. And then on that, we can demonstrate that there's now a created by property and a modified by property that are all generated simply through the declaration that appears on line 9.
So one thing that's worth noting is because you can get these records that are basically one-liner classes for you, it is something worth considering about figuring out where they get placed. Oftentimes people like one class per file. You could end up with a lot of one-liner files where your namespace takes up more lines than your actual record.
However, there's something interesting to mention too on this on these positional members, and that is that they're read-only.
Correct.
So by default, in fact, there's no way to change this. The members that are automatically generated in this test are going to be read-only. So Kevin's going to go ahead and try to assign.
Let me interrupt really quick. I've had a couple questions asking what the benefit of this syntax difference.
That is a wonderful question. So one of the things that Mark kind of just alluded to right there is that these properties are effectively read-only. So there's I realize it's tiny on my screen, but there's not a public get set that's sitting on them. There is a get, and then we'll come to it in just a moment, but an init on there, effectively making these properties read-only, which makes these generated record types immutable. So for people who've worked with immutable types before, they come with a lot of benefits in that they tend to be easier to reason about through your code. And then by definition, they're also thread safe. So things like the C# compiler, Roslyn, their entire object model is immutable by definition, just to give them that level of protection and performance. So the thing with records, I would say, is that before you can do immutable types in C#, this is now, they are now a first-class citizen.
Yeah, I think it's probably going to be easier for us to answer that question at the end, and maybe even have you guys help us answer the question as we go through the different advantages and features that are involved. You'll notice that there are also some caveats. I guess you could say, and times that you don't want to use records. And so once we've finished sort of demonstrating all the features that are included with the record, it's probably a good time then for us to review the question, which is an excellent question, because what will happen for you as a developer is you'll have to make the choice. When do I want to use a record and when do I want to go ahead and use a class? Similarly to the way you had to ask the question, when do I want to go ahead and use a struct and when do I want to go ahead and use a class? We have similar kind of constraints that are going on with a record, and we sort of need to define what those criteria are. So let's keep answering that question as we go, but at the end, let's try to do a summary, and you guys can help us sort of come up with what are the places that you want to use record rather than class, and vice versa. Wow, that's a lot of code you wrote there, Kevin, while we're answering questions. So you'll notice that Kevin tries to assign the values to modified by and created by, and when we do that, we're going to get an error that pops up and said, hey, these properties are read-only; they can't be modified after the object's been instantiated. There's a really interesting characteristic about the during construction kind of scenario here. In line 22, we've gone ahead and instantiated the object, and it's fully instantiated. But we can actually extract that code out, and let's go ahead and sort of do a modify record test, if you like, where we'll go ahead and modify the values inside this class. And in this case, we'll sort of demonstrate the nature of the fact that it is immutable, and what it would take to go ahead and mutate it if we actually need to do that. One of the ways I really like to think about records is to think of them sort of as to behave like a struct, or have struct-like behavior. Now, it turns out we can do something completely different than what we're showing here with records, and we're in a constrained scenario in this example because we've used positional members. So on line 9, we've gone ahead and used the parentheses following the data type. We've gone ahead and used parentheses to define the members of the class, and we don't have any additional members defined, just those two. And as pointed out already, by default, those two members are read-only and can't be modified post-construction. However, Kevin's gone ahead and created a creator or a factory for this object, the create fingerprint. And you'll notice there it takes in 2 parameters, and then he's going to use an expression bodied member. And he does the new operator without fingerprints. So there he's going ahead and just removing the need for us to define what the data type is on the right of the operator. And then he goes ahead and uses an initializer. And the key thing to note is that it's an initializer, so it's happening not as calling the constructor that was originally there, but it's actually calling the initializer, and then we're modifying the value modified by. And even though modified by is a read-only member, as shown in line 24, we are able to go ahead and set the modified value through the initializer. And one of the key features of a record is that it is read-only once it's instantiated, but instantiation is not complete until after the initializer is finished running.
Yeah, I think that is the key thing to point out, is that this new level of letting it do it, it gives you the convenience of using your object initializer to create these record types without necessarily needing to rely on always either overloading your constructors or adding optional parameters and just causing that constructor bloat every time you have a new, say, optional thing that you want to tack onto it. You can start to leverage this alternate syntax as well.
Yeah, and I think the thing I would add to that is that it's not only the fact that the value for modified is optional, but that it's still read-only. The key distinction here is you can obviously have n number of parameters that can be changed post-construction because the property is read-write. But in this case, modified by is read-only, but we haven't gone ahead and defined it as a construction parameter because we only have one required construction parameter. In this case, it's going to be the created by value. Modified by value is optional because of the assignment of null there in the record declaration. And instead, what we've gone ahead and done is made sure that we can still specify any number of properties in the initializer, the curly brackets following the new. We can go ahead and modify and change those to be whatever we want it to be. So any properties that you would have, even though they're read-only, are actually modifiable through the initializer.
Before we move on from records, we do have a couple questions coming in. I didn't know if now is a good time to answer those.
Sure,
Fire
let's
at
do that.
will.
Okay, also, Mark, your mic is getting pretty staticky if you have another option.
I do.
Great.
Switch right now.
All right. Kelly asks, can you generate C#9 records with database first EF core via the Scaffold DB context EF tools command?
Oh boy, what a very highly specific question. I will take a couple stabs at that. So for people who haven't been watching .NET Conf, I encourage you to do so. The EF core team kind of took a bit of a stab at a similar question earlier today, where the question was raised about using records with EF core just in general. And one of the things to remember is that records by default are going to be immutable. We'll get to how you can change that in a little bit. Which immutable objects
records with positional members,
correct, are immutable, and if you want a mutable record, you have to do some extra typing, which doesn't lend itself well to working with as an EF entity where effectively you want to say update a record in a database. That's sort of something where like the entity tracking wants that information in there. The database first bit of that question, I'm going to have to punt and say I don't know. The EF core team just dropped new documentation for the new version of EF core that's coming with .NET 5 this morning, and I haven't had a chance to go through it yet. aka.ms/EF core, I think, is the URL. Don't quote me on that.
Also, Steve asked, what's the benefit of a record versus named tuple? I don't recall if you answered that fully.
So not quite, and we'll get to that. So with a value tuple or a name tuple, like what's being indicated, is those are structs or value types, whereas this is a class with additional nicety to it. So there is a little bit of a difference there, just with the subtle difference between structs and classes, whether you pass by val or pass by ref. These are classes, so it'll be passed by ref. And there's other benefits with records that you won't get with structs as well. So we'll dive into those in a moment.
I think also there's a conceptual difference that value tuples are rarely used in an API, and they're really within the life or scope of the methods that they're being exposed by, rather than a first-class citizen that you're going to be using as part of your API and is reused across a lot of members. It's not to say they can't be, but it would be unusual. It would have a little bit of code smell if you did, to go ahead and use a tuple, again, a C# tuple in this case, that sort of spans the scope of the method with which they're being instantiated or returned from. It can be done, but it's not advised because it's not a first-class citizen.
Great. And we do have one more question before you move on. Stokes asks, do I have to use .NET 5 to utilize C#9 features, or can I use these features in .NET 3.1 or older?
I don't know what .NET 3.1 is.
I was going to say that's cheating. So I was able to get records and init properties plain nice in .NET 4.5. I don't think they're
yet to be defined.
Thank you. I was able to get records and something that we've yet to define working in .NET 4.5. I don't consider older versions of .NET still in existence.
Well, I think you meant .NET Core 3.1.
Oh,
and the answer is yes.
Oh yes, .NET Core 3.1 most certainly. But I was able to get almost all of these features running back to .NET Framework 4.5. And so or I should say, yeah, the vast majority of what we're going to show here is highly backwards compatible. There's some guidelines we'll get to at the end of stuff you want to consider if you're building a library and wanting to target a large number of frameworks.
Okay, any other questions?
I say we keep going.
Sorry,
Okay.
not right now.
So I don't know if at this point is worthwhile, Kevin, if we want to show the fact that this is underneath the covers, this is what the IL looks like for something like this.
Let's not scare people yet. Let's modify a record.
Okay, just go ahead and modify it. So to do that, what we're going to do is because it's read-only and you can't go ahead and change the value of a record because everything, it's immutable, what we can instead do is copy the record. And in doing the copy, we can create a new one with different values, but only specify the values that we want to be different inside the initializer, and I use the initializer term here loosely, for the properties that we want to go ahead and change. So we're going to go ahead and take FP, and we're going to go ahead and do it with a new syntax using a contextual keyword of with. And then we're going to go ahead and put the initializer syntax after the with, and we're going to modify the record modified by, and instead specify that it's buttercup here for the modified value. And so you'll notice there's no change to the original instance of FP. We are truly creating a clone of FP and then putting in or injecting in different data for that new record.
Yeah, this is the key thing that's been painful in C# before with immutable types is once you have something immutable, how do you modify something that's immutable, right? How do I get a new instance of it with the data that I need in it?
Correct.
Sorry, keep going.
No, I think you said it well. The end result is that what we end up doing is modifying it in a way that gives us a new instance, and therefore we don't have to worry about thread synchronization or anything like that, because we always have a new instance on every single copy that's created, and we don't have to worry about it being modified by multiple threads simultaneously. And that's a pretty significant feature. If we go back to the question earlier about when do we choose to use records versus when do we choose to use classes, one of the key things here about this is it's very easy to go ahead and define an immutable object as demonstrated, and also the fact that we can then work with that object or copy that object or create copies of that object with the new data that we need, because it went through some kind of, I don't want to say modification, but we needed to update it so that it had updated data. I think that covers everything we wanted to show on a record with a positional member.
Yeah, so I think let's jump on to the next one, because I think a lot of those questions that came in were around when would I pick this over a class. So let's do that comparison with a class and just kind of show what it's going to be, right? So imagine that you were to go and try and implement this yourself, right? Because the question is when is a record valuable? And I think the easiest way to answer that is saying, okay, imagine you had to go and write all of this by yourself. So if we have a new, fingerprint, right? And we're doing nested classes just so I can avoid naming collisions as I change files. And we've got something that looks kind of like what we had before. So the constructor looks like how we were interacting with our previous record with a required created by and an optional modified by. And we've got a couple properties. We can see that our create test lines up nice with where it was, but our update properties test is now immediately different than what we had previously, because before we weren't able to set it. So if we were going to try and get that same type of behavior here, now we got to do something different. So we could go through and we could do something with like a private set, right? And now we can start getting our same compile errors, or we could even go as far as making this a read-only auto property and get similar behavior there. And that kind of gets us a little bit closer to where we were, right?
Yeah, the difference obviously here with the private setter is that we can't use the initializer to change the values. So if we go ahead and instantiate it, instantiate Fingerprint Class in this case, and we try to use an initializer to modify the modified by value, it will error out saying, hey, as the class that's trying to instantiate this, you can't modify it because it's private, and so it can't be changed. Which begs the question of what exactly is going on that allows this to happen for records, that this can become possible. And the key piece that makes it possible is a new contextual keyword called init. That changes the way that the modified by value property, can be set. And what init says is that it can be changed as long as the constructor is not finished running, or it can be changed as long as the object is not fully initialized, I think is the term to use.
Yep.
As long as the object has not been fully initialized, the value of any initable property can be modified. And in this case, what we're saying is when we call the constructor, there is still some additional time inside the initializer where the value will be set. But if you look at sort of line 41.5, you try to change modified there, which we can't because it's one line. But if you can imagine we have a variable to do this, we could not change modified after the initializer. And so there's additional time, a wee bit of time before the object is returned and fully initialized, where the modified by value can be changed through this init, through the new init-based modifier on the properties setter.
Yeah, I think I'd say it one more way too, is you can think of this init option here as a slight expansion of a standard read-only auto property. If it's got an init on it, which the init goes in place of any setter, it allows it to be set from either inside of a constructor, just like a read-only auto property was, or an object initializer. So you just get that additional or bit to be able to do it. And it is worth noting that if you do an initializer like this, it is not required. There's nothing that guarantees that somebody has to call this. So for example, I can do that and get away with it. So, okay, so init keyword, we get down there, and now we get down to this kind of weird thing too, right? Is if you were going to go through and write an immutable class like this of figuring out, you know, how am I going to go through and try what the record's doing? Now I have this problem of, now I need a new fingerprint. How do I get one? So for example, if I want to go through and do something like this, right, where I've got an existing one, I want to go through, oh, that's not how you spell fingal. Everyone knows it's spelled like that. The question then comes, how do you go through and do this? And we can go through and we can generate up this method, right? And we can say, okay, now when I'm in here, I'm going to return a new fingerprint, right? And I got to copy my created by, and then I'll pass in the new that it called V because reasons. Modified by. And then we start ending up building all of these either little factory or copy constructor type methods every time we want to go through and create a new instance and copy the data across, right?
And in this case, we're specifically saying that only the modified value can be changed. We're not allowing the created by value to be changed, which is a little bit different than what we showed in the first example, because there the created by value and the modified value were both specified through the positional members, and so either one of them could be changed. We're actually making a business choice here and saying, or logical choice here, they're saying, well, no, we don't want to allow you to change the created by value, or we do want to allow you to change the created by value. In this case, you can. In the other case, we can't. And this is a great example to start sort of thinking about which way you want to go ahead and work with records. Through using the methods we've shown so far, which is all using positional members, you don't have control over what can be modified by the with operator, because that with method is generated for you, and you don't get to do things like constrain it to not have the created by parameter. Whereas in this case, because we're defining it ourselves, we do.
Right. Cool. Okay, so hopefully that kind of narrows down some of those times about when you might go through and choose, I guess, rolling your own class versus going through and using a record. So,
so it's worth, before you go on, Kevin.
Yep.
The other thing to mention is that you don't have to use auto props for init. You could actually have a fully defined
oh, certainly,
init implementation, and so it's probably worthwhile showing that, especially as we start to see
autocode button. Autocode button worked. I updated Visual Studio 16.9 this morning as soon as it dropped, because there's no way that's going to hurt a demo at all.
So you'll notice here that we've got a fully implemented property with a backing field, and we are using a init, in this case, an expression bodied member for the setter, and we're also going to go, we're just using init instead of set. And it has the same characteristics that you can go ahead and modify the modified by property through either the constructor or the initializer. One thing that I was a little bit disappointed by in doing this is I was hoping that there was some way to determine any time the modification was happening, as long as it was still within the context of the runtime of when the constructor was running. But it turns out the only place you can go modify the init is inside the property or inside the constructor. You can't go and have another method that perhaps you refactor, like an initialize method outside of the constructor, and have the initialize method go ahead and modify either of these values. That's not allowed. You have to put, you can only modify an init setter when you are inside the constructor or inside the property.
Yeah.
I just have a question on width, if now's a good time.
Sure.
They ask, when you create a new record with a width, can you immediately dispose of the old one?
Yes, it depends on, like any other class, if you've got any more references to it.
Because, so what do you mean? What do you mean by dispose?
Yeah.
I guess the question is, since we don't really dispose of C# objects, they just go out of scope. It's sort of hard to understand what that means. We can assign it to null, but the object instance still exists. And as soon as we assign it to null, we could not go ahead and use the width operator because we don't have a handle. So just by virtue of the fact that FP is declared, there is no concept of dispose. And in this case, where we go ahead and do on line 45, where we assign null, we can't call the width on it because it's an instance member, and you wouldn't have the ability to go ahead and do that.
Yeah, so I think the question's probably driving at the idea of, is this a separate brand new instance, or is there any link back to the original one? And I think the key thing here is this is a separate brand new instance with the data copied over, but there is no link inside of FP2 back to the original one. So this is effectively brand new instance, all new data.
Yeah, conceptually think of it as a clone, and by all new data, right? I mean, if they're both pointing to a reference object, they could be both pointing to the same new reference object, but it's essentially a clone. So it's taken every single, and this is important, I'll say it carefully here, it's taken every single field and copying the field into a brand new instance. So each field that's inside the object now has that value, and then using the initializer to change any of those values to something different. And the values can be changed through the properties, like created by and modified by, but the copy is created by copying the values inside the fields that are backing the property or are actually fields that you declare. We'll talk about that later, but a key point to notice here is it's basically looking at, conceptually even, you could think of as a memory copy of the fields to another location in memory, and then going ahead and initializing with new values through the initializer.
Yeah, so looking at our example here, a better way, if we were trying to mimic what a record would be doing, is it's actually in everything that the records end up doing in the generated code. Pretty much everything is going to be going to the backing field. So even auto properties have an auto generated backing field behind them. And everything the record's going to do is going to want to work with those fields. So whether it be the width, copying that data across, or any of the other features. Just be aware that if you start setting breakpoints inside of here and then questioning why the breakpoints aren't getting hit, it's likely because the records are acting on those backing fields and not necessarily going through your property.
Any other questions?
Not right now.
Cool. Should we go and customize one of these things? Because what if...
Do you want to show equality at all?
That's where we get next.
Okay.
We're getting there.
Sorry, I'm jumping ahead. You're not keeping up. Let's go, Kevin.
I was going there because
Okay.
What happens, Mark, if I don't like the generated bits? What if I want my own bits? Because reasons.
Yeah, so specifically what we're saying is when we went ahead and used the positional members in that first file, we specified and generated a constructor just by putting parentheses following the name of the data type. And the problem with that is you're stuck with exactly whatever the generated code is, and you have very little options to modify it. Sure, you can put an attribute on it, but that's pretty much where it stops. You can't go do anything more than that from within the space that the type is named and the end of the parentheses. However, it turns out there's still curly brackets that appear after the record declaration where you can go ahead and specify properties. So in the example that we're showing right now, you can see on lines 11 and 12, modified date and modified by, instead of defining them as part of the positional members up on line 9, we've gone ahead and moved modified by down into line 12, and then we've gone ahead and added another field for the modified date, and both of those are declared with a init. So both of those are read-write as long as the object is not fully initialized, and once the object is fully initialized, we go ahead and change that. And to demonstrate sort of how this works, we've gone ahead and written some tests here, and where we go ahead and use the with operator to get the data, to get new instances of the object, which we've named fingerprint 1, fingerprint 2, and fingerprint 3. Imagine that. Fingerprint. Excuse me, I mispronounced it.
Before you go on, I do have a couple new questions coming in. The first is from Austin. Can you initialize a new fingerprint with and then immediately point the old reference at the new fingerprint record?
So the answer is yes, but I'll caveat that a little bit. So again, remember, there's nothing overly special about records beyond their auto-generated classes for you. So yes, you could repoint your reference back at another one after you've done a with to create a new instance, because the with keyword is really just invoking effectively we'll call it a copy constructor for lack of better words. Invoking a copy constructor for you, tweaking some of the data, and then giving you back a new instance. So it's 4 characters and saving you having to write all of those copy constructors and figuring out how those work. But at the end of the day, they are still just classes that you can, if you want to reassign a reference back to a previous one, you certainly can do it.
And can modify date default to now?
Somebody is jumping ahead in our script.
Yes,
I'm going to defer until later.
All right. Kenny asks, you mentioned that these are immutable. Are they passed by value or passed by reference?
Passed by reference. They are classes. So reference types.
And one last question from Sean. Copying a large array of records using a with could then use, it's not really a question, could then use up a lot of memory since it's going to duplicate everything. Just a comment there.
Yep.
That's correct. So the way I would think about this is that you're essentially doing a clone, and clones is more than just assigning one reference variable to another. You're not just copying the reference; you are copying the data within it. And as soon as you're copying the data, however big that object is, which is measured by the fields, that's how much copying is taking place in memory.
Yeah, and it's worth knowing, like, immutable has a lot of benefits, but there are cases where it is not a silver bullet. You do need to consider your situations, and yeah, if you've got, say, a massive array that you don't want to copy around or make big copies of, don't do that. That would be bad.
And that's true, but I think what's important to realize is it's not implicit, right? It is a 4-letter word, and you sort of know when I go ahead and use with, I'm making a clone of the data within that object. It's not that you do an equal sign and suddenly you've gone ahead and copied all the data. It's you go out, do a with, and therefore you've cloned the data, and it's explicit operation. You can't, by mistake, do an equals and have it cloned. You have to go ahead and do use the with.
Yeah, and go ahead, Aaron.
Sorry, I just had a follow-up question on that from Steve. Do you like the decision to use the with expression context manager versus having a method on record?
I haven't had enough time to I think answer that. I've been playing with these things for a couple weeks. I think I like it. Haven't used it in any major projects yet. I've just done a couple side projects.
What's interesting about that is I'd like to say, well, you can choose, but the method generated under the covers is not accessible. So you can't go ahead and call the method explicitly. The only way to do the clone using the generated code is to use the with operator. And so it's a good question to talk about whether I like it or not. I think the focus for me has been whether the functionality is useful and how helpful it is. I haven't really been deterred in any way by the syntax that's enabled through using it. It's a good question.
I did get one other question. Do you need to move on first and come back to it, or would you like that now?
No, we're good.
Okay, Kelly asks, will the with keyword enumerate, i.e. numerable, I don't know how to say this, with the T in its cloning? Sorry.
No, so the with keyword is something that's only going to work on record types. So there are a lot of compiler checks around, is this thing a record or is this thing not a record? So we'll get to some of the limitations with records, and just know that the compiler is keeping track of what's a record, and it's not going to let you do things otherwise. So with is something that the thing on the left has to be a record.
Even if I mean, Kevin's right, it's not possible, but even if it was, all you got to do is worry about what data is copied, and it's only the data that's in the specific class, which is minimal in the case of IEnumerable. So, well, of enumerable, I guess it depends on how the enumerable implementation is done, because there are ways where it's memory intensive. So.
Kelly says he means a property in the record.
It would copy the reference. So you're saying if there is a record with a property that is IEnumerable, what would be copied? And since IEnumerable is a reference, it would just copy the reference.
Yeah, I think so. I'll take a stab at what he's driving at. So be aware. So from the perspective of a record, there are no properties. There are fields and there are methods. There are no properties. And so when it's doing that copy, it really is looking at the backing fields for all of these things. So for example, if you were to do, you know, because that's how old everyone clearly is, the width is going to completely ignore this. There is no backing field, right? This is effectively a method that returns an int. In this case, it returns the only appropriate int to a 42. But because there's no effective backing data for it to copy, there will be nothing copied there. So it's not looking at the properties, it is legitimately looking for the fields. I'll leave it at that.
Yeah, and just to clarify that statement, it's not that there are only fields when you have records, it's that there's only fields matter when you do the width.
Yes.
So it's not that, I mean, clearly if we're demonstrating here we have properties, but when you do the with clause, which is conceptually a clone, the only thing that matters for the clone is going to be the fields.
Great, that's all I have for questions for now.
Cool. So now that we've beat the with keyword to death a little bit, I think, so I was going to explain these two statements, but I think we've kind of gone through exactly what's happening here a little bit. So yeah. we have a new fingerprint, and then we make a copy of it, changing the modified by to be something else. And then we make a copy of the copy, changing the value back to a nego, right? And so the key thing here that you get with records is the question of equality. So, and I think I'm gonna abuse the true here real quick. So, and I'm gonna go through and do. So we're gonna say 1 and 3 are equal to each other, and 1 is not equal to 2. Yeah. Right? And so we'll run that test real quick. And the test passes. So this is one of the key things to note that you get with records, because one of the common problems with a lot of C# objects is people declare their object, they declare their constructor, they declare their properties, and then they carry on to use the object. And occasionally what will happen is you'll end up putting it in a dictionary or a list or similar, or something that wants to do equality checks on it. And then you'll have to go and implement those equality members. And you may use either the built-in Roslyn analyzers or third-party tools to auto-generate that stuff. But with records, you get all of that for free. So the record, by definition, implements IEquatable. So you get the equals operator, you get the hash code, you get the equals equals operator, you get the not equals operator, and all of that is built for free, and all you have to do is declare stuff.
Now, if we went ahead and changed line 14 and we made it something that was dynamic or changed to do something, so we could do an increment operator on there, perhaps?
Increment operator.
42 plus plus.
42 plus plus doesn't compile. I have to back it with data.
I guess yeah, okay. We'll have to do it outside the class. Well, let's do it on the date. Let's just use datetime now, like somebody suggests on line 11, I guess.
Hey, that sounds like a great way to break tests.
And we probably want to change the time because it is possible that the time it could execute so fast that we wouldn't know. So maybe between lines 20 and 21, we should pause for a short amount of time.
Long enough to be significant, not long enough to make me tap my fingers.
That would definitely not be a good thing. No tapping your fingers. So let's just think through the logic here. So in this case, we're going to go ahead and instantiate fingerprint 1, and it's going to start out with an ego for the created by and an ego for modified by as well. Then in line 22, we're going to go ahead and change modified by to buttercup, which explains why in line 26 fingerprint 1 doesn't equal fingerprint 2. Now, what's interesting in the case of the change that we made now is we're setting modified date time to be UTC now. So whatever the time is at that point, we're going to go ahead and modify that date. And so let's see what's going to happen in that scenario.
So let's go through and do this then, right? So we're going to do equal fingerprint 1. Let's do modified date, and then how about we'll just jump all the way down, right? Like that?
Yes.
I'm a glutton for punishment. Let's do it. Ooh la la. Okay, so let's go through and I guess unpack that a little bit, right? So, and actually, just for proof be in the pudding, let's do a debug statement just so that we can look at these two values, I guess.
I want to be clear. We're changing the modified date, not the created by date. Is that intentional? We're checking the modified date rather than the created by date, and we declared it as a modified by. It'll still work. It's fine. I was thinking that in the constructor, you'd actually want to set the modified date, not the created by date, but it'll work as long as people understand what's the concept.
And while you're compiling, Sean wanted to point out that two records with the same values using reference equals are different.
Two value, if you were talking about the reference equals, yes, absolutely. Those are definitely, and that is a very important thing to note. Let's see. Okay, 474 and 474. So you'll note that the modified date from this guy here, just to prove that they are actually doing the equality on them, right, is the ticks. This one ends in 474. This one ends in 474. I apologize. That is tiny, 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 tiny. But the key part here is when we do these clones, this initial value that was set up here is being copied across, I guess is the key point to drive home here, right? So the modified date got initially set to UTC now here. We waited some period of time. We then copied over all of the data, including the original modified date. So even though this thing has an initial value, when this thing used the with operator, this guy ends up copying the original value for modified date into fingerprint 2, same thing from 2 into 3, and we end up with the same modified date in both 1 and 3.
We do have a question on modified dates here. They ask if it is a pass-by ref, how is it immutable? Should not hash code and equal function implicitly have modified date, and is assert.equal redundant? And he says, what I mean was it should have already failed in line 25 before reacting to 28. Is that correct?
So sorry, I'm reading through this because there was a lot there, and I want to make sure I'm understanding this correctly.
I've published both of those for you.
Yes, thank you. So should hash code equal implicitly have modified date? Is assert equal redundant? And this, so it's worth noting that this assert equal is specifically acting on modified date, but you are correct. If the equals operator is implemented correctly, right, and this assert equals down here is largely there just to prove that even if the generated equals was, say, ignoring this value, that the value is the same in both of them. I think that's the point there. But yes, you are correct. The generated equals method does work, and we will trust the Roslyn C# compiler team to do a good job. And this does work as we expect. I think that answers the question. But yes, your assumption is correct.
Thanks.
Okay, have I detoured far enough off script, Mark, or are we good?
You're doing great.
I am.
Absolutely
We
excellent.
are on fire. So I guess the key thing, I guess the key takeaway from this one here, though, is the fact that records give you a free implementation of IEquatable with both the equals operator, equals method, get hash code, all that jazz appropriately implemented so that you don't have to do it, because that's hard.
Correct. And in our case, we can do an assignment to the property and set the initial value, but that will get overwritten when you go ahead and use the initializer. Right, so that's a really important point here. In line 11, we do assign UTC now, but the date that actually gets assigned to the clone is the value from what it was cloned from.
Yes. Okay, should we carry on?
Yes.
So close.
What was
What do you
that
got,
question?
Sorry about that. One other follow-up question. If it's a pass-by reference, how is it immutable?
So immutability just means that once it's created, it cannot be modified. If you have, so for example, right now we've just got string and date time, which are themselves also immutable. If, for example, you were to say put a mutable object here, say some person class that you might have, right? You may still be able to mutate its members, but you cannot change the reference to those members. Is that clear?
I don't have another response yet, but I will let you know.
Excellent.
I'm
So
going to repeat the question. If it is passed by reference, how is it mutable? So when what we're saying in this case is, if I go ahead and assign fingerprint 1 to let's say fingerprint 4. If we have fingerprint 4 assigned to fingerprint 1, they're both pointing at the same instance of the object, the one that is set with an ego and an ego. And you cannot change either instance no, let me rephrase that. You cannot change the same, they're both pointing the same instance and you cannot change that instance. It's important how I say that. They're both, fingerprint 1 and fingerprint 4 would be pointed to the same instance and neither one can be modified. And if you do, sorry?
Sorry, I was just going to say you answered his question. Thanks.
Okay. You mean we don't get credit? We don't get credit for answering? He answered the question? I'm just kidding.
No, you answered it.
Oh,
He
okay.
was just responding to let me know.
It was probably Kevin.
I'm claiming credit.
Okay, Kevin gets credit.
Okay, so let's carry on down our merry way then, because there was I guess one more interesting thing in here. So with all of these fancy things that we have, right? So we do have I guess this concept here. So the other thing that we said we might want to do, right, is do a created date, right? Because we've got created by, we've got modified by, and we'll kind of do the same thing here, right? Where we've got a created date set to UTC now, and away we go, right? And so if we drive down here, trying to look at where we were going here.
You're just going to go ahead and do a not equal on modified date.
Not equal on modified date. Oh, sure, right. So we'll do await, task, delay, long enough to make them interesting. And more importantly, make that thing go away. But I think the other thing that we wanted to show here too, and we kind of drove at this a little bit earlier, right? Is if we convert this guy to a full property. So and this whole idea of the records really wanting to act on the fields and not necessarily use the properties, I think is a key one to drive home here. So imagine if we go through and do this, and we can, for whatever reason, this thing has lost or is not yet been implemented the ability of converting to a full thingy-mabobber, right? So you can do the curly braces if you want to. So say when you modify something, you want to change the modified date to be, date time UTC now. Right? So we're gonna have a little bit of fun with this, and you'll note. So modified date is declared init, right? And I'm gonna go ahead and take modified date. We've got created date set to UTC now. Modified date has an init. I'm inside of an init, so it is legal for me to go through and assign this here, right? Because as long as I'm inside of an object initializer or a constructor, I have access to be able to go through and do that. And so then we come down to this fun test down here, right? So we've created up a new fingerprint. We're going to wait some period of time, right? And then we will create a new one, and we'll set modified by on it. Right, and then we'll come down to this idea of should modified dates be equal, or should those be changed, right? So run the test. As long as I do these in the correct order, my world's a happy place. And boo-ba, green.
So the important point to note, though, is that now in the test from line 30, the earlier test, we are now doing an equality check. The modified by field is being set initially, but now it's changed between those two values. So when we do an equality check on line 37, it's going to fail. Fail on line 37 because they're no longer equal, because we also set the modified by property, and so therefore the modified by date got changed, and the values are not going to be the same.
The important part is to just make sure you always run your tests in the right order and comment and uncomment appropriately.
Yes, exactly. And can you do that when you check in as well?
Excellent. Yes, I will.
Yes.
I will add that to the CI system right away.
So what you do is you comment out the test, then check it in, then comment on a different set of tests and uncomment the right one, and then check it in, and that should be fine. You should pass your build, no problem.
Correct. Yes.
We do have a couple comments coming in now. Sean asks, is a class inside a record mutable or immutable?
A class inside a record. So there is nothing special about this.
So so just to make sure, you're saying if there's a field that is a reference type, will it be mutable or immutable? And the answer is it's totally dependent on the way that reference type is defined as to whether it can be changed or not. The only thing that becomes immutable is the reference itself, not the data within the reference, unless the data within the reference is also defined as an immutable type.
Adam asks, does the order of property declarations matter for this modified by changing modified date? such as the modified date being copied from the source record after modified by.
So you can get yourself, so order can matter if you've done work inside of your init blocks, right? So if you've got one of these guys here and I've got properties that are, say, either copying or moving data around from multiple ones, these are going to go in the order that you've done them in. So if you've built some sort of implicit dependency there, it's on you to manage.
Great.
It's not necessarily just free, so you can certainly do it. And I think this was kind of the idea of what Sean was getting at, is if I add a mutable object to my record, this person still remains mutable, even though it's inside of a record. There's nothing fancy here.
Steve wants to point out that he understands it, but he doesn't like this behavior. And he also wants to know, can you get weird circular-like logic issues with this field level init functionality?
So the answer, I don't think there is. There's nothing new here in terms of the way the object works. Could you write code that modifies and does things in weird order? Of course, but you could have done, no, you're not enabled to do this in any ways that you couldn't have done before. So I don't think there's there's no new capability or new way to shoot yourself in the foot. I don't believe that that's being created here. If anything else, it's just easier to create an immutable class, which before was much more difficult. And more than that, you've created an immutable class with a clone method. So if we go over like what we're getting from records, in the example we showed sort of with the my record file, we essentially were able to define the entire class ourselves in the same way that the record type does. And there's no .NET core capability that's required in order to enable this functionality. You could define this just as easily as before. Well, no, you could define it just as much as you could have before. It just took a lot more work because you had to type it all out.
Yeah, and that is an important thing too. And the idea that there's no new way to shoot yourself in the foot was actually, I guess, in some ways a feature, right? Because records are also serializable. So like any serializer that, say, goes over reflection and just iterates over your properties and copies stuff around, so AutoMapper, JSON.NET, all of those ones that can do that reflection-based stuff, they can still invoke this after the object's been created, right? Reflections still can go stomping and do very mean things across your object, and there's nothing that a record's going to do to prevent that, right? This is the compiler preventing you from doing something bad and trying to give you some nice protections and clean syntax. But under the covers, we are still just a class that has a whole bunch of auto-generated code.
And is there a built-in function to convert record to JSON or XAML? Do we have to handcraft it ourselves?
So you can feed these records into
Serializers.
Any serializer that would handle a class. So if you want to convert one of these guys to JSON, create an instance of the record and feed it into your JSON serializer of choice.
And you can still decorate it. Obviously, in the example we're showing right now, you can still decorate it with attributes so that you can change the behavior of the serialization. And if you use a positional member, you can also put attributes on the parameters that are part of that define the positional member, so that those two you can affect how they're serialized.
Yeah, and we weren't actually going to show this, but I'm going to do it anyway, because why not go off script? So there's something that's existed in C# for a long time where you can.
I just want to mention, Kevin, that you didn't make it to 45 minutes before you started modifying the script. I know that was the goal. I just want to let you know. I'm just kidding.
Excellent. So the positional member that the record's going to use to generate up the property and the constructor and the equality and all of that jazz for you, you can decorate this up with attributes. And more importantly, if you want to, this actually exposes some fun stuff where if you say you want to put the attribute on the backing field of the auto-generated auto property, you can do that. So if you've got something with, say, your serializer where you need to, say, decorate your fields with something, right? You can go through and do this. If you want to decorate it on the property, right? You can do this. This sort of syntax for, I'm blanking on the name. I don't rename. No, there's I want to call it scope, but that's the wrong thing. This type of syntax with attributes has existed for a very, very long time. Most people just, there's never been,
Since C# usually,
yeah, there's just never really been meaningful ways to use it prior, right? Most of us are familiar with doing assembly : right, and doing assembly level attributes that way. But being able to do things on like property in the field has existed. There just hasn't really been anything meaningful to do with it. Now we've got meaning.
And the other important part about this is that although created by in this context looks like a parameter, you can decorate it with property attributes or field attributes, even if those attributes are restricted to only being used in a certain context, because the context of that positional member is multiple things. It's both a parameter for the constructor, and it's a property, and it's a field.
Yeah, so there's all of that fun jazz there. So
the other thing I would mention as a guideline here is when you go ahead and use positional members, we strongly would advocate from a guideline perspective that you go ahead and use Pascal case in that name, because that is going to generate a property that's part of the API. And we'd rather have the API for the property be a casing that follows the rest of .NET. And the sacrifice, of course, is that you're now going to have a constructor that has a Pascal case parameter. And so that's the sort of one sacrifice, is that when you go ahead and call new there, the parameter name for that constructor is going to be Pascal case rather than camel case. But we think that's preferable than going ahead and use camel case and having your properties in the wrong case.
Do you feel like this behavior breaks the spirit of how it should look? I'm just having a few comments on that.
Yes and no, but
is that regarding the naming or something else?
Yeah.
Probably the just what Steve was commenting on about the behavior. He said he felt like they were chickening out by allowing this type of behavior.
Yeah, so yes and no. Like on one hand, I don't know how else I would expect it to work, right? When you're trying to generate multiple things from a single thingy, how else would you expect it to go? Like any modifications that they do to it would then be an opinion on somebody's favorite naming standard. Even if it's their own, and they try to not necessarily force you to follow, or I should say, they try to give you enough rope to hang yourself, right? Like if you want to have your own particular naming standard because people get, very strongly opinionated on their personal favorite one, then the C# team tries to not restrict you from doing that, right? So I think for me, what I would say is records I see as a huge advantage, because I am very sick and tired of having to write these types of objects over and over and over. And more importantly, even when you're using the stuff to say auto-generate your equality methods, right? That's great for the first version of your object, and then you go and add another property. And now you got to like maybe delete all of the equality members, regenerate, and hope you didn't mess anything up or miss anything. Whereas now, I just type it, and I'm done.
So I think I have mixed feelings on the positional members. They seem like an amazing shortcut, but they remove the capability for you to do validation on any positional member. So if you have, for example, a non-nullable created property like created by, you have no way to go ahead and do validation that the value is actually not null. Or if you said, hey, this is first name and last name, and you want to make sure that first name and last name cannot be white space. On a positional property, you have a positional member, you have no way to do that. And that so just using records with positional members and then relying on the positional member is disappointing. And I'm also disappointed that I couldn't overwrite it. So what I really wanted was I wanted to put in things like the created by positional member and then provide a constructor that verified that the created by was not an empty string or not null. And I couldn't do that because you can't have both. So in line 15, if we removed the comment and we wanted to have the constructor in line 19, the compiler doesn't allow that. And I would have much preferred the compiler to generate the constructor if I hadn't defined it. But if I had defined it, I would like the compiler to allow that. And so that I could go ahead and add things like validation. Similarly, ideally, I would have my validation in the property, not on the for read-write properties. Actually, we didn't talk about this yet. You can actually have read-write properties on records as well. So we could go ahead and define a property that's read-write. We hadn't done that at all. So there, for example, on line 32, we've got a read-write property. There's nothing about record that allows me to do validation or do anything different. So there's no behavior change for how a read-write property is defined. And it's important to note that you can have records that are mutable because you could define your own properties that are read-write. And so what you're getting by default is only what you get by default from the positional members, not by what you define yourself. And you can actually take records and you can have mutable records. So it is not a true statement that a record is not mutable. It is not mutable if you use positional members and only positional members, but anything else you add, you could certainly choose to opt in and make it modifiable. My disappointment, I mean, to summarize, my disappointment is the fact that I can't do a bunch, it hasn't made doing a bunch of other stuff like property validation or parameter validation any easier or any different. And my hope was that I could still do that.
Yeah, so and the other big one, like with the nullable reference types, there's nothing magical about this that in any way makes nullable reference types easier or harder. So
yeah, you're still gonna get warnings. There's still a bunch of cases that you have to jump through and do sort of gnarly code because it's there. It hasn't really been some of the problems that came out of nullability features in C# 8 have not been addressed in C# 9.
Yeah, so just be aware that that is definitely a thing. Okay, so I guess a few other things that we kind of hit on them there a little bit is you don't have to leverage the positional records, right? This is if you just want to get and say, you know what, please don't generate stuff for me. I want to do, my own constructor, my own validation, but I still want the benefits of the record type where it's going to do like the equality and whatnot for me. You can get that, right? Like we showed that a little bit earlier with the modified and the created date. You can still get that auto-generated stuff and say, okay, hands off, let me write some of this stuff myself, right? But again, there's not, even though you do kind of have a little bit of a middle ground, it's not perfect. I think that's the key message there. The other thing that the record type gives you, specifically that the positional record type gives you, is you do get a deconstructor. So just like you can break apart a value tuple into its individual parts, if you have a positional record, you can also break it apart into its individual parts, and that will get generated for you as well. You do not get that deconstructor if you don't use a positional one. So it's worth noting the things in here, in addition to generating stuff, one of the additional things they generate is a deconstructor with those parameters.
Yeah, and what's nice about that one is I feel like it's fully customizable because the deconstructor is created in this case only by created by member, but you of course can create your own deconstructors because you can just overload it, and so that allows you to go ahead and put additional deconstructors in the system to support other fields that you want to spit out when you use deconstruct.
Okay. Anything else? Have we done enough with records?
There is a couple cases where you want to be very careful about using records. For example, if you have two objects whose identity is determined perhaps by a GUID or by a social security number, and you want to go compare those two things, you have to remember that the generated equality operator is on all fields within the object, whether they're explicitly defined or implicitly defined, like an order property. And so if you're trying to implement an equality operator that only pays attention to the things like the social security number or some GUID, and that does not pay attention to other fields, you would have to do that yourself. And so records would not be appropriate where identity is not based on all fields within the object. And so there are specific cases where using records are not a good choice. My default inclination is to start using records by default and prefer records over classes, but there are specific cases where identity would make that not ideal. And I think the other context about this is you want to use it in the sense where there is a set of data that's important about your object, and the primary purpose of the object is sort of to store data, not behavior. A good example that Kevin and I talked a lot about is sort of things like a service or a controller are probably not good candidates for doing records, because their primary purpose is really about behavior rather than about data themselves. And in fact, we tend to discourage keeping state on things like controllers and services.
Yeah, so some general guidelines that we had come up with. One thing that we didn't call out and show, but the compiler will whack you upside the head if you try it. In your inheritance hierarchy, records cannot derive from classes and classes cannot derive from records. Again, this is one of those areas where the compiler is going to very much enforce it. You can have interfaces, right? Like we said, records implement IEquatable for you as well. So interfaces are fine, but the moment you need to say either derive from a class or have a class derive from it, a record is not the right choice at all. I think maybe we just hit some of these because I think we're at the end of what we were going to cover on records and some of the guidelines that we had. So some of the ones we had already hit on before that I don't think are overly shocking. So the positional records. So avoid positional records when you need to do additional validation. So similar to like what we saw over here where we want to effectively validate, say, is null or white space on created by, because even though we've got nullable reference types turned on and this is a non-nullable string, there is nothing in the generated code that's going to actually say do a null check for you. So just be aware that when it generates up the constructor, all it's going to do is take that string in and pass it forward. So be aware that if you need to do extra validation on those types of things, a record is probably, or specifically a positional record, is not the right answer there.
You cannot do validation on the members that are placed into the positional placement. So the constructor of the record, you cannot do it there unless you define your own.
Correct. And more importantly, you couldn't stop somebody from bypassing it. So the other thing, the init properties. So this is one of those features that was added in C#9, and it was added to support record types as far as what it came out of. But there's nothing about init in your properties that is limited to records. You can use that wherever you want. The key thing to remember, though, that we hinted at the very beginning is there's nothing that guarantees that anybody's going to actually call that in an object initializer. So be aware that it's a great expansion if, say, you have an optional read-only property. You could expand it out with the init to give people using your object a little bit more freedom in how they construct it. But if it's a required value, again, you don't have that level of validation to ensure that it was called. So it's somewhat limited in its application. If I missed anything.
Required value meaning the object is not in a valid state unless this value is set.
Yes. And then just for people building out libraries for backwards compatibility. So init properties are backwards compatible. Like I said, I got them running all the way back to .NET Framework 4.5 with a little compiler hackery. The key thing to be aware of, though, is if you rely on just the init as a means of being able to assign a value into that property, somebody on an older compiler is not going to be able to do that. So you're going to end up wanting to make sure that you define a constructor or some other, I guess a constructor because it's init, means of being able to set that. So either an overloaded constructor, optional parameter in your constructor, or otherwise, to make sure that somebody without that extra syntax can do it. So if you're looking to target a broad audience, be aware that there is some backwards compatibility to consider there.
And just to clarify, if I use a standard constructor with initializer, I still can set a property with init. So it's not just the fact that you can't use the with operator, because of course you don't have that syntax. But even if you just use a standard constructor and then you want to do an initializer on the init, you can't go ahead and set the value on that initializer either. Is that correct?
Correct.
Kevin? Yeah.
Yes. So just be aware that you want to leave a C#8 or similar method of assigning to that. And then the naming, I think we already covered with the Pascal case.
There's one additional one we should add is it used to be, there's frequently a discussion about when it's appropriate to use var or not use var. And I think the new syntax, which allows you to go ahead and put the data type on the left, and then just the constructor without the name parameter, I think I would, as a guideline, I would say always do this. This is a case where I don't think you ever need to specify the data type on the right anymore. You can always use the left to go ahead and rely on it. The only exception, I shouldn't say always because there is an exception, the exception being that if you want to go ahead and get a parent type, for example, so you want to do a cast at the same time, then of course you're going to have to go ahead and do the data type on the left that you want, even though on the right side it's a different data type because you're relying on cast to get it to a different member, a different type.
Right. Yeah. So yeah, exactly what Mark was saying is, and especially because with var, you kind of.
Could you write that down, please, Kevin? Whatever I say.
Yeah, but I don't want to put it there because I'm about to overwrite that in a moment. So mental note created. With var, you kind of ended up with this awkward bit where you were looking back and forth at your types as far as, you know, what is my type? I have to look to the right of the line instead of the left. Now with this sort of syntax, in most cases, you can keep all of the types on the left and you can sort of read it left to right the way my brain likes to work. And as everyone will tell you, the way my brain works is clearly normal.
Although it may not be clear.
Clear as mud. Definitely clear as mud.
Okay, I think we're done with records.
We have done this, and I might just bounce us forward real quick, if you don't mind, Mark, just to, in the interest of speed and grace on some of this stuff. So through the magical incantation of Git, and I click buttons, and I click one more button, and all this stuff is there. Ha ha ha. Yay, Git. Okay. Pattern matching. We've got new pattern matching syntax.
So the first thing that you're going to note in this example that we're showing is that now you can go, there's a sort of another contextual keyword. So we've already talked about one, the init keyword, and the width, two actually, and the width. But you'll notice now there's another contextual keyword that's highlighted in blue, and that's the and contextual keyword. So now we can actually go combine. On the left-hand side, we're assuming that it's operating on the operand of the switch statement. So here we've got a switch statement, so percentage. So we're basically able to go ahead and combine two operators without using percentage in the comparison on 13. It's just implied from 11 that that's what we're comparing. And we're going to go ahead and say that percentage is less than 0.5 and it's greater than or equal to 2.0. And if it is, then you're going to get an F. And so you continue through that pattern throughout. But there's the ability to go ahead and do an AND operator to compare two different values and not specify percentage in every case.
Yeah, so the other thing that I want to make sure is pointed out here is with the update. So we already had switch statements since she's C# yield
Expressions.
Yeah, this is using a switch expression, and then the expansion in C#9, in addition to these extra pattern matching bits with AND, is you also then end up with these being able to do inequalities as well on them, so that you can now get access to these ranges. Whereas before you kind of ended up with this weird syntax with using like when and whatnot to try and get this level of stuff, or you just threw in the towel and said, I'm done with this, I'm writing a bunch of if statements. Right, to try and build this out, and now it flows significantly nicer. And just like the previous switch expression stuff, order of operations matters. That hasn't changed since C#7.
The other thing too that's important to note is that those are constant values.
Yes.
So you need to have a constant there, because this is essentially equivalent to sort of a case statement, if you like, very loosely thought of. But you can't go put a non-constant value in them for the comparison. This is a constant that's defined there. And so you would need to go sort of back to the older syntax if you wanted to go and do variable values in there. Continue on with the and, you'll notice on line 19 we've got an or as well. So you can do the same thing with an or statement to go combine statements with an or operator. And
not. Don't forget.
The
other thing, we have parentheses in expressions now too.
Ooh,
they work exactly like you expect. Spoiler.
Yes. The other thing is, you'll notice there in line 19 that we no longer, we actually can't notice because it's not there yet. We should actually change this. If I'm correct, Kevin, you can delete object from line 20. The variable, there you go. Yeah, that's what I meant. Thank you.
Yes.
You can
C#9, the magical expansion where we can now delete single characters.
That was 2. You deleted 2 characters. You got to make sure.
I got rid of the space and the underscore.
Yes, yes. And if you put more spaces, we could count those too.
That's true.
So again, very minor, but there is the ability to go ahead and delete the discard there, which for the underscore wasn't technically a discard, it was actually declaration. So. And one last one on line 29, you'll notice that we can now have an is not null comparison operator for null. So if you didn't have enough ways to compare null, we now have another one for using is not. In this case, you can is not. So take the not operator, put it inside null. In C#8, we had the ability to do is null, and now in C#9, it's a significant change because now we can do is not null as well.
Yeah, so basically just the addition of the not into the expression pattern matching. There's one more thing that we've got sort of somewhat hidden and embedded in line 29 as well, is you'll note this static keyword that's sitting down here as well. So we can now decorate our Lambda expressions with the static keyword. Contrary to what I initially thought, this does not somehow make the generated method behind this static at all. All this static keyword does on your Lambda is it makes it so that you aren't able to reference or close on variables. So you'll note if I go through and make the Lambda on my select static, I'm no longer able to effectively capture this variable. So it's basically a way of you sanity checking yourself, similar to how in C#8 we got static local functions, where they were just like local functions, except for they were explicitly not able to capture things from the outer scope. Static lambdas are basically the next extension onto that, is they will prevent you from being able to capture things from the outer scope. So
yeah, and this is a place I would also sort of add, I think there's a coding guideline here, is I think generally you should try to use static and do that by default until you explicitly recognize that you are doing a closure and you've decided, no, it's appropriate, the closure is the way I want it to behave. And in some ways I was a little bit disappointed. I was hoping that static would just be there by default, and then I'd have to opt in, but it turns out you have to opt into static behavior. So it's sort of opposite the way you want to, but that's clearly for version compatibility reasons that was necessary to do that. So generally going forward, I would say use the static keyword unless you intentionally are choosing to have some kind of closure over a variable that's outside of your scope.
Yeah. So a lot of
sorry.
Go ahead.
One other thing I'd mention on line 29 is you can't go ahead, even though you're saying is not null, you cannot declare a variable at the same time.
Yeah, there is no on the end of this guy. So.
And even if you use this as a switch statement, it's the same syntax, but you can't declare a variable after that, which also is a little bit disconcerting because there's cases where I think that would be useful. So that was sort of an example where I would like to have been able to declare that variable, but you can't, and you'd have to go back to other ways to look for null. such as object or curly brackets.
Yeah, because it's worth reading this, as this is basically the same thing as what you had in C#8, where you can do X is null, except for they added one more thing. And even in C#8, X is null. You weren't able to pattern match off the end of that. So just be aware, it's just a straight expansion of that. The one other thing I'll point out here, see, Mark, I'm going to go off script again, is we do have the ability of, say, string, right? Right, so in C# 8 land, you could go through and declare a delegate like this, and we could use set up the two parameters for the action with this. In C#9, we have legit discards, so now you can delete one of your underscores. And if you have a third parameter,
we just saved ourselves on 3 characters. Is that true?
That is correct. Yes.
Yeah, that's excellent.
So,
that's great.
So
you should upgrade just for that.
In delegates, you do have legit discards now. So, woot woot.
We have a couple questions coming in. This one I'm going to post because I'm not quite sure how to say it. Jared wants to know if it's a better practice to use X is not null or X exclamation point equals null. I'm going to publish that so you can see it.
So I think
we said that wrong.
Yeah, so that's probably one. Mark was working on getting a blog post up on our various null checking methodologies, since we're up to way too many right now.
So I can,
yeah,
I'll give you a reference. So here we've got, I'll get the URL we're at while we're doing this. Let me just post something. So we'll update this URL, which I think will answer that question. It's not, I haven't updated it with this new syntax for C#9 yet. But I think that's probably the best way to handle this question. It turns out there's a lot of ways to check for null and a lot of ways to check for not null, and they do have some advantages and disadvantages. And so we'll get that blog updated now to support the is not null syntax, which wasn't available before.
Yeah, the spoiler alert is there's not necessarily great ways, and it's important to understand what you're doing and make an explicit choice based upon whatever X is going to be. So
one of the key things that drives your decision is whether you want to be able to check for null on a struct, on a value type. So obviously, if you write code that checks for null on a value type that could never be null, that's compiler determined. You should never actually be able to write that code. And certain ways of checking for null will let you know that with a warning, and certain ways will not at all. And so the preferable syntax is to always make sure you get notification by the compiler whenever you've gone ahead and written code that is unnecessary.
And we also have a question if you recommend any book for algorithms and data structures in C#.
I think I'm gonna somewhat punt a little bit. Send me an email, and let us get back to you on that one. I think that's the correct one, unless you've got something off.
I don't. Okay. I mean, clearly, you know, it should be fairly obvious which book you could recommend, but you know.
Well, you can go ahead and recommend it. You have quite a few people who are new to this, and several who are not in Spokane, so feel free.
So what Mark is, because Mark won't brag, I will brag for him. So Mark is the author of the Essential C# book series. Essential C# 8.0 just came out. Be aware the book is somewhat designed to be able to take somebody from 0 to fairly high level, and it is a fairly thick book as well. So for people who've been working in C# for a long time, I recommend starting and looking at the in the back on the index, because it's got a breakdown of, say, new stuff per like the last, I think, couple versions of C#. So if you're just saying, hey, I want to see what's the latest in C# 8, you can see the breakdowns of that and find it that way. So just be aware, if you're going to read it cover to cover, if you've been doing C# for a while, you'll find some of it you hopefully already know.
And then somebody else asked a question about comparing C# with Java. And I will make one comment, sort of, hey, how close are they? There is a lot of similarity. Obviously, they both derive from sort of C-based languages and things like that. But I look at sort of a lot of the structures, like up and through the point of covering classes and even interfaces, there's a lot of overlap between Java and C#. So upgrading, I use that term carefully, upgrading from Java to C# is not a huge learning curve. But as soon as you get into concepts like link, I think C# really starts to take off. And so that's really been one of the key pieces of functionality that I think starts to make C# sort of become a better language, is you start getting the functionality of link and even some of the task-based APIs that start to make it exceptional.
Yeah, and for what it's worth, my first language was Java, and then I picked up VB.NET, and then the jump into C# was fairly easy, and I didn't look back. So if you're learning Java,
never bothered to learn another language. Is that what you're saying?
I'm saying be careful if you start learning C#. You might not want to go back.
That's true. I think that's true. So like with my book, for example, I think if you started at like chapter 6 or 7, where you covered the basics, you could just learn mostly the C# stuff for the remaining, whatever, 15 chapters.
So unless you have something, Aaron, I was going to jump us forward because I'm trying to watch time and what else?
Sure.
We've got at least 2 more things we want to talk about.
Sure. Just one quick question just there. I know C# 9 just came out very recently. Do you know if there's any blogs or books?
As in today?
Blogs or books on the subject that are already out? Or is that
so
still?
docs.microsoft.com. But it is worth noting, like, and for people who are interested in seeing a lot of it, .NET Conf started today. There's going to be recordings posted at some point, and I believe it goes 2 more days? Question mark. So if you are interested in checking that out to learn more about it, I highly recommend it.
Great, thanks.
Okay, so another thing, again, this is one of those kind of, it felt a little more fit and finish type, smoothing off some sometimes rough edges, is we now have covariant return types in C#. So that's
all you need to say.
Perfect.
I'm kidding.
So back in ye olden days, like before today, you ended up, if you were going to override a method, the return types had to exactly match. But now, for example, if you want to override and you can spell, you can now have the overridden method return either the same type or a derived type, hence the definition for people who aren't familiar with the term covariant. So we now have covariant return types for virtual members. So huzzah. It is important to note just a couple things on the usage down here. So for example, even though, so we create a derived instance, right? We call a create on it, or a clone, or whatever you want to call this method, right? And we get a derived instance back out. But if we call the create on this base virtual member, the compile type is going to be base, even though at runtime this create2 instance will be a instance of derived. At compile time, this is still base because it doesn't know that this is going to be returning out a different type. So just keep that in mind as you're going through it. For the most part,
that's relevant. For example, if you went to declared on 924 a var.
Yes, yeah, this is one of those, again, one of those cases, and we would definitely advocate for avoiding var in cases where the type isn't obvious. And this is one of those cases where now invoking virtual members, var is now less obvious than it was. So, and I do not know why.
That's a bug.
I agree, it's probably a bug. So you'll note I am on a preview version of Visual Studio. I downloaded 16.9 when it dropped this morning because, again, what could go wrong with my demos? Okay, I think that one's probably simple, straightforward. Okay, another big feature that dropped, and this is only loosely related to C# 9, and at the same time, somewhat related to .NET 5, is we now have the ability to use what are called code generators. So for people who have wished and dreamed for aspect-oriented programming in C#, this will make you go, yes, oh, not quite all the way there. And that's what it is. It is great. It will let you generate code, as the name implies. It does not let you modify any existing code. So So I want to be clear on that. You can generate new code. You cannot modify anything in an existing assembly. For that, you have to fall back to all your previous IL mucking tools. So PostSharp, FODI, etc. So for this particular code generator, we aren't going to dive into the bowels of it for how it works. The code for all of these samples is going to be posted out on GitHub. It's actually there now. And at some point,
I'll put the URL.
Mark's going to go grab the link. So if you are interested in diving in deeper, you can go and look at this. But in short, let's imagine, for example, that you work for a company that likes to ensure that you have really good code coverage across all of your stuff. And even though you have nullable reference types, you're still doing your due diligence of checking incoming arguments for null. And darn it, I don't want to write unit tests over every single one of these throw argument null exception cases. That is a waste of my time. So the common solution is you do something with reflection, which works, right? But it comes with the issue of reflection is slow, right? And so how could we go about doing something better? So what we end up having is there are be big. We have these generated tests that this code generator will actually go and generate this out for us. So we've got a second project up here, this code generator with null checks, and it generates out code that looks like this. So it's generating me out a unit test class for X unit. It's explicitly going through and it's checking my constructor. And then it's very explicitly passing in null and just iterating through each of the parameters and saying, I pass null here, and I verify that it throws an argument null exception with the appropriate param name. And then rinse repeat all the way through all the other parameters. So source generators are awesome. And oftentimes any place where you find yourself needing to do sort of that aspect-oriented reflection stuff, I could imagine things with like dependency injection libraries where maybe you're doing a bunch of registration, that kind of thing, where you want to make it automatic, but you don't want to take the slowness of doing a reflection-based approach. This is the advantage of source generators. So the only change to the language that really happened to make this possible is there's a slight change of the way the word partial works. So if you were to generate a partial method, it now allows you to effectively generate the other half of that partial with a code generator. So
in this example, what Kevin's done is he's gone ahead and generated the tests to go against this class in an entirely different type. But you can also imagine doing it within the same assembly, the same class, I guess is a better way to say it, because you can be that specific. The key thing to note, however, is you can't modify existing code. Maybe I was distracted when you said that, Kevin, but you can't modify any code that's already there. So if you wanted to say, oh, let me automatically check the service here in this case to generate this because it's a non-null type coming into the constructor on line 11, you couldn't generate the code for the argument null exception so that it was just there rather than just writing a test to verify it's there. Ideally, you'd write it so that the code generator would generate that check because you can't modify an existing method. However, it is actually possible that you could declare line 11 as a partial. Actually, can you just constructors as partials? Well, at least for methods you could.
No, constructors aren't partial.
But I think you can do it on a method that's
yeah. Methods can be partial, and that's the sort of the relaxation. As before, partial methods were very limited. They had to be private, only void returning, all of that jazz, so that the compiler could easily take them out if there wasn't an implementation there. Those rules have been relaxed so that you have time to generate up the implementation of those partials with a code generator if you want. So
we could generate it so that it checked the parameter based on an attribute or something like that, for example.
Yeah, and so for people who are interested, down at the very end, we've got a summary file, and so there's several links out here to some of the documentation. Again, this can get a little bit hairy to go through. Because when you're writing a source generator, you are working with the Roslyn APIs. So you get handed a copy of what the compiler sees as your compiled project, and you're told generate what you want and add anything that you would like. And the key part is add anything that you like. You don't get to go
Can't
and
modify.
yeah, you can't modify it, even though there's some methods on the compile unit that it hands you for like removing syntax trees. Yeah, they don't do anything. And that's very much intentional and by design. So this gives a good expansion into aspect-oriented programming, but not, again, it's not all the way there. So just be aware of that. Okay, I think
We've got one more feature.
We got one more
features, actually.
We got one more feature.
Two more features.
And oh, we were going to write it by hand, but I'll just click on it.
Oh, so
I'm going to collapse
you
it.
should delete.
So,
Yeah, there you go.
Here, boom, boom. You can now write hello world in one line of code in an empty C# file. So .NET new console app, and then this becomes everything. You no longer need to specify a namespace. You no longer need to specify a main. It's just there. So the question then is, when would I use this? And the answer is it is great for demos. It is great for if you're just testing something out in like a C# sandbox. So for those people who have a folder of console apps 1 through 45, this is for you, right? It's great for quick and dirty stuff. Unless you're doing something very simple or something to demonstrate, it is. I don't think it's necessarily great for production-y level stuff. Because
so
really all it is an empty one.
Yeah, the other case where you might find this start to be useful is just so think of the concept of C# scripting.
Yeah.
So C# scripting is supported today, and you can do this thing in C# scripting, and so they've now essentially made that same functionality as available in the language itself in C# without going to the scripting framework. But notice you can only have one of these files. You can't have more than one file that is a top-level program. You can just have one, and so we don't think it's likely that this will be used in production level programs, and that's the purpose is sort of a scripting type approach. It would be unusual otherwise.
Yeah, and all the same sort of rules about only having one main method in your assembly, and all of those still hold. Is the compiler sees this as an auto-generated main method, and so if you try to declare a second one, you get the usual error about, hey, too many entry points into my assembly. You got to tell me which one you want, that kind of thing. So just be aware this is an auto-generated public static void main, and like all good programmers, this is where we start. But now we get to start with significantly less code.
Stink. That means I have to change chapter 1.
I know. Your opening example to your book is now even easier than it already was.
Yes, exactly. Which is significant, honestly. I mean, the other stuff you got to explain name, you got to explain class when you're just trying to get hello world out. It is. I think this is an improvement.
It is. It is significantly easier. So I will put back the code that I subtly hid away from everybody a moment ago. The other wonderful thing that's coming into C# is module initializers.
As in has come to C# 9.
Okay, module initializers have existed in the runtime since the dawn of time. People just don't know they exist, and you have to do IL prior to C# 9 in order to play with them. Now you can just write code. So you declare a method that is public static void, you put it inside of a static class, and you decorate it with this attribute, and this method gets invoked before any code inside of your assembly runs. So this is slightly different than, say, a static constructor, because static constructors get invoked before the first time that class is accessed. But say you have some library like Xamarin Forms where there's this basically a static init method that you have where you've got some amount of setup that you want to do in your assembly before anyone does anything else. You can now, rather than telling people in your docs, hey, you have to call this init method and then you're free to do whatever you want, you can just write a module initializer, and the runtime takes care of making sure this is invoked at the point your assembly gets loaded. So just be aware, that timing is key at the point your assembly gets loaded. So when your module's actually being initialized out of your assembly, that's when this is going to get called.
Kevin, we didn't try this, but I assume it wouldn't happen if you're loading it by reflection. Do we know?
If you what?
If we were loading it through reflection?
Oh, no, module initial. Well, okay, so that depends on the runtime and the load context. So if we assume .NET Core, there's assembly load context, and there's things like reflection only load, which would not invoke it, versus load from file, load from, etc., that would cause it to get invoked.
If it's closed for load for execution, then it would be run.
Correct.
But
So
if it's
unless you
closed
do
just
some,
to run
yeah, if you
documentation,
do the
or something
reflection
like
only
that, it would
load,
work.
you will bypass module initializers, but by definition, reflection only load is there for inspecting types and that sort of thing.
Not executing code.
Correct.
We are nearing the end of our time, and I do have a few questions
goodness.
before we wrap up. So I just wanted to make sure, just let me know when we come to that spot where we can ask those.
No,
we can fire at will. I think we've reached the end of my the script that we put together. So everything after this point is off script.
Great.
You want to show? Hold on. There is some additional features we can show in the summary, Kevin.
Oh yes. Oh yeah. Okay. I lied. So we do have a summary thing. So we didn't actually touch on all of the C#9 features. Most of these features, I would argue that if you need them, you already know about them. So things like native size integers, function pointers, suppressing the emitting of locals init flag. So if you are familiar with the low level IL and what that means, you probably are already aware of this feature. And then some smoothing up of get enumerator support with extension methods. So if you are interested in seeing that, the first link here will take you to the docs page that will get you off to the races.
Even there, it's pretty high level, so you sort of have to start coding, get those, because they're not going to be commonly used. So yeah, getting in depth and understanding them takes some work.
Okay, now I'm done.
All right. Meg would like to know, does this support a return if it's just a function behind the scenes?
What's this? Well, she was probably looking at
yeah, we've got a little
covariant return types.
Covariant return types back here.
Yeah.
If it's just a function behind it,
Meg, if you're still here, feel free to add a little more to that question.
So it is a function in this case. So you'll notice that create is a function. And so it does work for return types on a function. So I think we're probably not understanding the question.
Okay, let me see. It looks like she says to clarify, this is top level statements.
There's the context we were missing.
We have to know. We have to be to associate which slide are you looking at when you go ask the question.
So the answer is, so it supports the returns that a main would support. So you have the grand choices of void, int, task, and task event, I believe are the choices for your main, because this is just going to auto generate you a main method. So you are still constrained by the return types of what you would get there. So if you're looking to hopefully use this as like a C# REPL type thing, that's not quite that.
And you would specify that by the return statement. The compiler would know what you were returning, and you would have to be consistent in your return statements.
Great. And the last question that I have here is more for people who are new to C#. If there's any flaws you'd like to share about C#, and if it's, they just said they know it's commonly used in video game development.
Well, I think the easy way to answer that question is just say no.
Well, so yes, but I've seen that a lot. So. And I would say for people who are new to C#, it might be worth actually checking out some of the sessions at .NET Conf, simply just to look at the breadth of stuff that's covered. Like, you don't even need to watch all the sessions. Just kind of scroll through and look at what's covered, because you'll see everything from mobile app development, web stuff with ASP.NET. You'll certainly see
browser development with C# using Blazor.
Yeah, Blazor and WebAssembly type stuff. I mean, there's certainly game development that happens with like Unity. I think is usually where that comes from, because it's quite popular there. I'm trying to think. As far as like explicit flaws with C#,
yes.
Mark will happily point out all of the ones that he hates. There are definitely areas, specifically around a lot of the new features introduced in like 7, 8, and now C#9, that have rough edges.
Yeah.
So
I think
But
I think it's easier to think about in the context of, the language has been around for 20 years now. That's a long time for a language to exist. But if you compare it to, languages like C++, I think they've been much more structured and careful about what features to add, and when they add them, that they're not going to regret having the feature in the future. And so there are features that are now in C# that have essentially become obsolete, I think is probably a good word, that we no longer use, or syntax we no longer use anymore because it existed in the first versions, but they're no longer necessary. And you could consider those to be warts if you like, but if you just don't use the feature, you don't really notice. And a lot of people who started later after the first versions don't even know they exist because they never come across them. So I think I would say yes, there are some flaws, or there are some warts, but if I compare it to a lot of other languages, I think it's far less because of the strong discipline that the C# design team has in making sure that what they're doing is gonna carry forward as best as possible. But they do not have foresight into the future and to know exactly where it's gonna go, what's gonna happen.
Yeah, and it is worth noting that just because at the speed at which they release and have been updating, that even though they may release things that feel like they've got rough edges or need to be smoothed out, quite often what we see is in subsequent releases, a lot of those kind of problematic areas start to get easier and start to get better. So like I don't think this will be it's not that record types are going to get dumped in and then away we go. I'm fairly confident that in future versions of C# we're going to just see the usage of them get easier and some of those rough edges get smoother and that sort of thing. So one thing I was going to point out too, if you would like to start playing with C# 9 now that you have it, there are 2 requirements. Assuming you want to work in Visual Studio, you need version 16.8 or newer. 16.8 went GA this morning, so you can download that and install it, and then simply set your Lang version to 9.0, and you are off to the races, and you can have at it. Be aware if you're targeting something like .NET Core 3.1, you should be fine without issues. Obviously, .NET 5 or Net 5 is got all of the latest bells and whistles, and the migration path from .NET Core 3.1 to 5.0 is change your target framework. It's outside of some esoteric situations, it's usually that simple. Older frameworks, there might be some stuff. If people run into upgrade problems, feel free to ping me, shoot me a message. I may end up even doing some streams on upgrading some of my existing projects, but I've revved 2 of them already, and it was a fairly painless process.
Great. Well, thanks so much. I just want to point out again that our next meetup is December 8th for the Essential.NET group, and it's going to be on Essential.NET 5.0, the state and future of .NET. That'll also be with Mark and Grant, who spoke earlier. And if you want to get another meetup this week, you can sign up for GitHub versus Azure DevOps, What's Your Future, with the Spokane DevOps meetup. And is there anything else before we close, Mark and Kevin? Again, thank you for doing this meetup.
No, I'll just plug that DevOps one. I've worked with Phil on like GitHub Actions and DevOps. He is awesome. If you are at all interested in CI/CD or any of that stuff, you should definitely go to it.
Yeah, and I think if you've got questions, especially about the move to GitHub and when to use GitHub versus Azure DevOps, I think it's going to be very important to attend for that reason as well.
And I will say that meetup is going to be different. That will be a Teams meeting that's more of a roundtable type group, so you'll be able to actually speak to Phil.
Okay. I want to thank you guys. We appreciate you coming, and feel free to contact us. We've left some contact information there, or you can reach us on Twitter. I'm Mark. I'll put mine, Mark. And Kevin is Kibo.
Yeah. Social media platform.kibu.dev. There was a link up earlier, but I will drop mine in.
And you can always ask any other questions in the comments of our meetup page. We're happy to respond to you there as well.
Great. Thanks very much, everyone.
Perfect.
If you have any feedback, let's just send us emails. That'd be great because we'll be doing this again. So.
Thank you.
Great night.